Hello everyone. Today we are going to talk about SKLearn pipelines and why do we use them and what are the benefits of using them in a machine learning exercise. So there are different ways in which we build our machine learning, right? So first I do SQL treatment, then outliers, then I fit my model, and finally I predict it. So I can build these individual blocks, or I can build a single assembly line where I'm doing these things one by one, and at the end I get a single pipeline out of it, right? So the benefit is that whenever I get a new data, it will pass through all of these steps, and finally I'll get the prediction out of it, right? So but if you are seeing this fit step over here, so it is not applicable for test data. It is only used when we are training our pipeline or our model, right? So we'll quickly see how to do it in Python. So for this particular example, I'm going to use a dataset called as iris. So it's there in SKLearn datasets. SKLearn datasets contain multiple datasets, but we are going to use iris for our example. So using load iris, I can load the entire data. Let's say in this object called as data over here. See what does data contains. Data contains lots of things, right? It contains these variables which you are seeing, and targets. It has these four features: sepal length, sepal width, petal length, petal width, and using all these four, it has also given us what is the type of flower we are talking about. So there are basically three kind of flowers: setosa, versicolor, and virginica in this case, and they are encoded as 0, 1, 2 in our data. So data is in NumPy array format. So using pandas, we'll convert them into a pandas data frame. So using pd.data frame, I can convert them into a data frame which I can use. So data.data contains the NumPy arrays, and column names I am giving as sepal length, sepal width, petal length, and petal width. And the target variable, which is the type of flower, it is stored in data.target. So we'll add that to our data frame as well. So I'm creating a new column target over here. So now you can see that this is in the ordered list, right? First it contains setosa, then versicolor, and then virginica. But for our modeling exercise, we need it in a randomized fashion. So we'll use sample function out of pandas, which will help me to randomize these values so that I can use them in my model building. So I have done the reshuffling of my data. Now as any machine learning, when we deal in real way, we won't get data in this format. There will be some missing values, but right now my data doesn't contain any missing values. So next I'm going to add certain missing values in it. So using this NumPy functions, so I'm iterating through all the columns, and if column is not equals to target, then I'm going to replace random 10 observations with missing values. So using random dot choice, I can select random indices. So I'm selecting 10 indices over here, and I'll replace these things with np.nen or missing values. Oh, I have to replace in with if over here, right? So we have inserted missing values on our own, right? So obviously the next step would be to divide our data into test and train. So for that we are going to use SKLearn's train test split function. So here I am using 30% data as test and remaining 70% data as the training. Right. Now because we have missing values in our data set, so we will replace them with mean, but before that my data also contain target, so let's drop that. So axis equals 1 is for columns and 0 is for rows. So I've dropped it from train. I'll do the same thing with test over here. Now my independent variables are ready. Now I'll treat those missing values which we had inserted. So I'll replace them with the mean of individual columns. So I can achieve that by using pandas fill any function. So extend dot fill any, I give xtrain dot mean, so it will replace all the missing values with the means, right? So I'll do the same thing with test. So xtest dot fill any xtest dot mean, right? So now my data doesn't contain any missing value. Now I can directly use it for my model building. So for model building purpose, I'm going to use decision tree classifier over here with the default hyperparameters, but you can use any algorithm of your choice. So first initializing the decision tree classifier, then we'll fit it using the train data clf dot fit xtrain comma ytrain. Using this I have trained my classifier. Now if I want to predict it on test, I have to just put clf dot predict and the data I want to predict on. Okay, so they are the predictions which I have got from my decision tree classifier, right? But if you have noticed, there is an issue that we have replaced our test data missing values with mean of test data itself, but ideally I should replace it with train, right? So this is a small step, that's why we can run it again. So in order to build the correct model, I'll have to rerun everything. Let's rerun and see how does it look. So this was a small mistake and the data set is small, so we could go back and correct it, but it's not possible in real life scenarios because you would never know where you went wrong, and there are multiple people working on the same project, so it's very difficult to identify such kind of small mistakes and correct them, right? So that's where SKLearn kind of helps us to build pipelines in such a way that we avoid such kind of mistakes, right? So I'm going to use pipeline module from sklearn.pipeline, which will help me to build pipelines. So building pipeline is very easy, we'll see. So I'm going to use this simple imputer from sklearn.impute module to replace it with mean. So pipe is initialized by pipeline class. So it takes argument as a list where we need to pass tuples. So tuples are nothing but the steps which we have. So right now I have two steps. The first one is the imputation and the second is model. So for imputation I am using simple imputer. By default it uses mean, and for modeling I am using decision tree classifier, same as previous. So my pipeline is ready. Let me just run it. It's okay. Cool. So my pipeline is ready. Now what I have to do is I have to train it with my train data. So the fit step will train the entire pipeline and not just the model. So the other different steps within pipeline. So first imputation, then decision tree classifier. So once I have fit my model or the pipeline, next I have to directly use raw test data, and it will take care of all the missing value imputation and using model for prediction, right? So it's so simple. So it has given me these classes over here based on the model we had trained. So you see that SKLearn pipelines makes our life easier. The code is more readable and more easy to debug if we face any challenges, right? So that's the reason we use pipelines as a single assembly line for any model building exercise. Okay, so next we'll see a small example on Python classes, that how to use Python classes, how to build them. So here if you have observed, we have used multiple classes, right? The simple imputer, decision trees, all of these are nothing but classes, right? So next, see how can we build classes. So I'm going to build a example class. Let's say I want to build a calculator class. So every class has this method called init. So init initializes a class. So whenever you initialize a class, you are essentially calling this function. So you see that there are three arguments which I have written: self, num1 and num2. Self is just referring to the instance of the class itself. So while I am going to initialize the class, I am going to pass only num1 and num2, because self is just a reference to the instance itself. Okay, so I can store these passed argument within the class. So self.num1 is nothing but num1 over here. Similarly, self.num2 is nothing but num2 over here, right? Now I'll add two functions. Let's say I want to return addition of two numbers. So I'll just return self.num1 plus self.num2 as an output. Pretty simple. Similarly, I'm going to add a subtract method where I'm going to return the difference of these two numbers, num1 and num2, self.num1 minus self.num2, right? So I've created my class. Now I can initialize. So let's say I'm initializing it in object name, let's say calc. Okay, so I have to write CLC as calculator and pass two numbers which are nothing but num1 and num2. So let's say I pass 10 and 2 for example. So I have initialized the class. Now I can access the variables and methods within this class using this initialized object CLC. So let's say what CLC dot num1 contain 10, correct, num2 dot contain 2. Now to access methods is same as accessing variables. So calc dot add will return me addition of these two numbers, right? Similarly, I can call calc dot subtract and that will return me difference. Now I can create one more instance of the same class with different numbers, 5 comma 3 or 5 comma 2 for example. So this will, let's say, what is the addition? It's 7. So basically calc and calc1 are two different instances of the same class, so they have different properties though they are instances of the same class, right? So the reason why we have explained classes over here is because many times we face situations where by default methods which are there in SKLearn are not complete enough for our use case. In that case we can create custom classes and use them in our SKLearn pipelines. So I can use any method where I want to use for my pipeline, right? So basically when you are going to use any external class in SKLearn pipeline, so you have to take care of few things. So you should have fit and transform methods if it's a transformer like missing value imputation, and you need to have fit and predict method when you are using any model for predictions, right? So they are the basic things which we'll use, and so there are few things which are apart from whatever we just mentioned. Let's say for transformer we need some other methods like fit underscore transform, where we want to fit and transform at the same time. So you don't have to write all this together or on your own. So these base classes, base estimators and transformer mixin will take care of that for you. So you have to just write init fit transform, and these classes will take care of other remaining things for you. Okay, so let's say I want to do some exercises. So I want to multiply my sample columns with, let's say, 10. So the way to create classes is class sample, but now I have to use these two base estimator and transformer mixin classes so that my sample inherits the methods defined within these two classes. Okay, so like any other class I have to first write init method. So within init I'm going to store the column names for sample, right, because I'm going to use them. So I'll write self dot let's say vars, and I'll store sample underscore length and sample underscore width, because I want to multiply these two columns with 10, right? Next requirement is to write fit. So though fit is not doing anything over here because we are not learning, so but as a requirement we need fit and transform both. But let's say if you want to learn something, you have to write it in fit over here, right? But right now I'll just pass it. Now within transform, the objective was to multiply these two columns, sample length, sample width, with 10 and pass it. So that's what we will do. So I'm returning x and var names and multiplied by 10. So it will multiply sample length and sample width by 10 over here, right? Similarly, say I want to multiply my petal length and petal width with 5. So I can do that, but before that let's see how does this work. So I'm initializing the class within sp. I can call sp to transform on iris, so it should multiply my values by 10, right? So it's correct. Now I can go back and multiply my petal length and petal width with 5. So I'm going to copy this code and replace apple with petals. So petal length, petal width, now multiply it by 5. Okay, so we are done. So these classes are ready to be consumed within SKLearn pipeline. We'll see how can we do it. So I'm going to import SKLearn pipeline and one more thing called as feature union. So as you have observed that sepal and petal classes are returning only two columns. The first one is returning sepals and second one is returning petal length and petal width. So I need a way to combine these two data frames into single one, and that's the job of feature union. So I'll use the same pipeline class to create pipeline for me. So now we need to use first feature union, and within feature union we'll use these two classes. So you can consider feature union to be a smaller pipeline within a pipeline. So within feature union again I need to pass two tuples, the first one being the sepal, second one being the petal, right? So let me write this. So sepal class, I'll write it here, and petal class I will write it here. Okay, so basically previously I had two steps where we were doing simple imputation and then we were building the model, right? But now in this case I have added one more step, which is transforming my variables. So sepals I was multiplying by 10 and petals I was multiplying by 5, right? So this is the previous pipeline. I can write it with two arguments or two tuples within a list. So first one was simple imputer, then model, but now I have added the first step, which I can write it here. So the overall schema remains the same, but this feature union I have added to combine sepal and petal outputs. Okay, so the first part feature union is done. Now same as previous, I have to add imputation method over here, which is simple imputer in our case. In second tuple I'll pass model, which is decision tree classifier in this example which we are taking. Okay, so my pipeline is ready to build. I'll just run it. Okay, now I need to fit it based on training data, X train, Y train. So my pipeline is fit. Now I have three steps within it. One is feature union, second is imputer, and the third one is model. Again you can pass hyperparameters within decision tree if you want. Now I need to use predict method to predict on my test data. Let me write pipe2.predict, and within data I will write X test. Right, so I've got the predictions. It has done all those sepal and petal imputations and did simple imputation and give me the final predictions. Okay, so that's about pipelines. So you have understood why and how do we use pipelines. So that's it for today. We'll see you tomorrow.